Mirrors are the product of some fascinating chemistry. In industry, mirrors are made in a few different ways, but they all use a metallic material such as silver to achieve reflection. Some manufacturers use a system of nozzles to spray silver or aluminum onto treated glass to make high-quality mirrors. Others use high-tech ovens to vaporize those metals onto glass. The pressure, temperature, and bake time can be controlled to produce metallic films with atomic-level precision. But you don't need sophisticated equipment to make your own mirror at home. David Smith, a British designer and glass artist, recently made waves on social media when he recorded himself creating a perfect mirror out of ordinary glass. The silvery substance he describes is actually real silver. The shiny metal appears to magically drop out of a simple water-based mixture and onto every crevice of textured or smooth glass surfaces. The result is stunning and takes only seconds to appear. Just what kind of sorcery is Mr. Smith meddling with? Let's take a look at the chemistry behind this seemingly magical act. Making mirrors out of silver and glass is actually a nearly 200-year-old craft. The method was formally introduced in the mid-1800s by the prolific German chemist Justus von Liebig. Von Liebig sought a method for producing looking glasses that wouldn't, in Victorian-era parlance, make workers mad as a hatter. You see, up until then, the most popular mirror-making method involved the use of mercury. Gilders, as they were called, would slide glass over tinfoil that had been flooded with the liquid metal. The mercury would react with the tin to produce tiny islands of reflective crystals that would trap the liquid mercury. Unfortunately, the absence of modern safety standards meant that workers would often succumb to the noxious effects of mercury. They suffered weakness, tremors, and delirium, symptoms shared by the mercury-using hat makers of the same era. Von Liebig did away with the poisonous metal altogether, opting instead for silver. The process, as demonstrated by Mr. David Smith, involves freeing silver locked in a compound known as salt and making it stick to glass in its metallic form. That starting salt is silver nitrate. Mixing 1 gram of that with 1 gram of sodium hydroxide transforms the silver nitrate into silver oxide. That's the cloudy substance that can be seen being formed here. But adding just the right amount of ammonia and giving it a stir produces a colorless liquid composed of happily suspended silver ions. Now's the time to act quick, because those ions won't be too happy for long. If left sitting for more than a few hours, this solution can start to form silver nitride, an unstable compound known to spontaneously combust. On top of that, silver nitride is highly poisonous. So follow Mr. Smith's example and make sure you're working in a well-ventilated area and wearing protective equipment. The final step before pouring is to sweeten the concoction with about 4 grams of sugar and mix well. But be sure to use the right kind of sugar, because here, molecular structure is everything. The result is a perfectly reflecting mirrored surface and hopefully the look of satisfaction at a job well done. It might look like magic, but then again, science's best acts always do.